Okay, welcome back everybody. So we are going to finish this very rather large section 6.3 on properties of trigonometric functions by talking about so the last video we talked about the sine and cosine. Now we're going to talk about the other ones, the tangent, the secant, the cotangent, and the cosecant. So let's look at this. Let me remind you what these are. The tangent is the sine divided by the cosine. The secant is the reciprocal of cosine. Cotangent is cosine divided by sine, and this is also going to be the reciprocal of the tangent. That's one way of thinking about it. And the cosecant is the reciprocal of the sine. Okay. So some properties. First off, the secant and the cosecant, they're going to either be less than -1 or bigger than +1. And the reason for that is that remember, we know that the sine, the sine of theta in absolute value is less than or equal to 1. So when we take the reciprocal of this, it makes sense that this is going to be greater than or equal to 1, right? All right, so for example, if the sine is 1/2, the reciprocal of that will be 2. Okay, so this shows you that the cosecant of theta in absolute value is greater than or equal to 1, which means if this is positive, then it's greater than or equal to 1. If it's negative, that means it's less than or equal to -1. Okay, and the same thing happens with the cosine. The cosine is between 1 and -1, so it's reciprocal. It'll have to be greater than or equal to 1, and so secant is greater than or equal to 1. So that's why that works. The tangent and cotangent, however, that can be any real number. Okay, the tangent might be between 1 and -1, or it might be outside of that range. And we've seen one example. The tangent of 30 degrees is 1/√3, so that's less than 1. But the tangent of 60 degrees is the √3, and that's bigger than 1. Okay. So the tangent and cotangent they fall in, can be any real number. So in a fancy way, we say as functions, we say that the secant and cosecant, the range of that is going to be all the numbers less than or equal to -1 or greater than or equal to +1. And we would say the range of the tangent and cotangent would be all real numbers. It's a fancy way of saying that. Okay, so let's see, when is this defined? Now we know that the sine and cosine are always defined for any value of theta. But we have to worry about, that's not true for the other trig functions, because you're all dividing by something, and you can't divide by 0. So you just have to remember, like the tangent will be defined whenever the cosine is not 0. Okay, if the cosine is 0, then this tangent is undefined. Same thing with the secant. Okay, and the cotangent and the cosecant, they'll be undefined if the sine of theta is 0. Okay, so we say that this is undefined when the tangent and secant is undefined. This is when the cosine of theta is equal to 0. And if we remember from our last video, that basically is all the values of the form plus or minus pi/2 plus 2 pi k. Or another way to think about this is, or when theta is some odd integer times pi/2. Okay, so same thing. And then the sine of theta is 0. Okay, well, when does that happen? That happens at any multiple of pi, and any integer multiple of pi. So that's where these are undefined. Okay, the next two identities really come just from the fundamental identity. Okay, remember the fundamental identity said that the cosine squared of theta plus the sine squared of theta is equal to 1. Well, if you divide both sides by, divide everything by cosine squared, okay, and break this up, this will be cosine squared over cosine squared of theta plus sine squared of theta over cosine squared of theta equals 1 over cosine squared of theta. And then this means, then this is just going to be 1 plus, and this is sine theta over cosine of theta squared, and this will be 1 over cosine theta squared. Okay, so this gives us that, it gives us 1 plus, this is tangent of theta squared is equal to secant of theta squared, okay, which is exactly what we have up here, just in a different way. Okay, and remember, we have this, we write, when we're taking powers of a trig function, we write the exponent between the trig function and the argument, okay, to avoid confusion. In a similar way, we can get the this other identity. We have the if we take sine squared, so which one do we, well, I guess it doesn't matter. Sine squared of theta plus cosine squared of theta equals 1. We now, if we divide by cosine, rather sine squared, we get sine squared over sine squared plus cosine squared over sine squared equals 1 over sine squared. So this will be 1, this will be cosine over sine squared equals 1 over sine theta squared. And of course this is just 1 plus the cotangent of theta squared equals the cosecant of theta squared, okay, which is exactly what this says, okay. So these last two identities are really just come from the fundamental identity. We're just dividing both sides by something. Okay, let's look at the next one. So we know that the sine and cosine are periodic, and with period 2 pi. So if you add 2 pi to an angle, then the cosine and the sine doesn't change. And it won't change the tangent either, but it turns out if you add pi to an angle, that also won't change. And the reason for that, so we have the tangent of theta plus pi is equal to tangent of theta. And similarly, we'll see the cotangent of theta plus pi is equal to cotangent of theta. So in fact, we're saying that tangent and cotangent are periodic. It's that the period this time is pi and not 2 pi. And the reason why this works is as follows. If we take any line that goes through the origin, that will intersect the unit circle twice. Okay, if AB is one point, then the other point is going to be minus A minus B. And this is true because this is a straight line, or this is supposed to be a straight line, the way I drew it, meaning the angle from here to here is 180 or pi radians. Okay, so now the reason why the coordinates are opposites of each other is because if we draw a triangle here and draw a triangle here, these are going to be this distance and this distance are going to be the same, and this distance and this distance will be the same. And you know that means that is really all you mean. This positive distance would be A, and this positive distance would be B. So that's why that works. Okay, and then so when you have a so let's say if this is theta and this is pi theta, or so this is theta and this is pi, the coordinate of this would be cosine theta sine theta, and this would be the coordinate of this would be Now it would be minus, it would be minus cosine theta minus sine theta, okay, according to this. So, but these are also, this is also the point that corresponds to the angle theta plus pi, okay. So the tangent of that would be, the tangent of theta plus pi would be minus cosine, or rather minus sine theta over minus cosine theta, plus pi. Actually it would be this coordinate. So this angle here, from here to here, would be theta plus pi, and so the tangent, of course, would be the cosine of this angle would be negative cosine theta, and the sine of this angle would be minus sine theta. So we divide these, but the minus signs cancel out. Okay, and then we get, and this is just going to be the tangent of theta. So that's why that works out. And the same thing can be, you can prove cotangent this in the same way, just by flipping the sine and cosine. Okay. The secant and the cosecant are periodic, but the period is 2 pi. And the reason for that is, for example, the secant of theta plus 2 pi is 1 over the cosine of theta plus 2 pi, which is 1 over cosine theta, because cosine is periodic, a period 2 pi, and then this is just the secant of theta. So that's why that works. And similar proof proves this. And then the finding whether these values are positive or negative, that corresponds to just finding, remembering what these things are. So the secant, since the secant is 1 over cosine, the secant is positive whenever the cosine is positive, and the cosine is positive in the first and fourth quadrants. 1 over sine is cosecant, so cosecant is positive whenever sine is positive, and that happens in the first and second quadrant. And then for the others, tangent, of course, is, we know that's sine over cosine. So this will be positive when sine and cosine have the same sign, okay, as if they're both positive or they're both negative. And that happens in the first quadrant and the third quadrant. And the same thing with the cotangents. This will be, because it's cosine over sine. Okay, so that's how you get these signs, this sign chart. All right, so that takes care of the properties. Now let's look at some examples. So let's find what some of these values are. In our first example, say if we wanted to find the cotangent of 5 pi over 3, this is the same thing as cosine of 5 pi over 3 divided by the sine of 5 pi over 3. Okay, and well, what is that? Well, hopefully you're memorizing your trig values. Okay, and if you're not, then we just look at our unit circle, and we see at 5 pi over 3, the cosine is 1/2, and the sine is negative root 3 over 2. So this would be 1/2 over negative root 3 over 2. Okay, you could see the 2's cancel. If you don't, you can write it this way. This is 1/2 times the reciprocal of this bottom fraction. And I messed that up, of course. Okay, and now we can see the 2's cancel, and we get 1 over negative square root 3. And you can, if you're on Pearson, you have to, I guess, rationalize it. You'd rationalize this, and this would be negative 3 square root 3 over 3. Okay. All right. What would the secant of 11 pi over 6 be? This would be 1 over the cosine of 11 pi over 6. And this would be the 11 pi over 6. Okay, so we look at that on our unit circle, and we see that the cosine is square root 3 over 2. Okay. Okay, which is the same thing as 2 over square root 3. And again, if you want to rationalize this, it'll be 2 square root 3 over 3. Okay. The cosecant of 45 degrees, okay, well, cosecant, that's 1 over sine, so okay, and if you look on our unit circle, this will be square root 2 over 2. Okay, take the reciprocal of that. And then this will be, you can cancel this, simplify it a little bit, and it turns out that's just square root of 2. The tangent of 210 degrees will be the sine of 210 degrees over the cosine of 210 degrees. Okay, 210, what is that? 210 degrees, well, 180 is pi, right? So add 30 or a pi over 6, you get, that's this one. So this is 180, add 30 degrees to it, you get 210. So that's 7 pi over 6, and the cosine is negative square root 3 over 2 and negative 1/2. And we want the sine, so that is going to be the y-coordinate. And the cosine is the x-coordinate. Okay, and this will, again, you can simplify this. The minus signs cancel out. So this will be 1 over square root 3, I think. Okay. Okay, good. So now let's look at this one. This is a case where we see if we're at this point now. We can find the if we're given the value of one trig function, we can find all the other trig function values if we know one more, or if we have one more piece of information about whether something's positive or negative. So, for example, in this case, cosine of theta is 1/4, and sine of theta is negative square root 15 over 4. So, if we want the tangent, that's sine over cosine, so this would be negative square root of 15 over 4 divided by 1 over 4. And this will just be square root of negative 15. The cotangent, here it's just, you can just flip this, or you can just realize the cotangent is 1 over the tangent. So this is 1 over negative square root 15. Okay, you can leave it like this, or you can say this is minus 1 over square root of 15, or if you want to rationalize it, it would be this. You can write it this way. Okay. If it were me, I'll accept this answer. You know, but if it's the machine, you know, it can be a little picky. Secant. Secant is 1 over cosine, and the cosine is 1/4. So you just have to remember what's the reciprocal of 1/4. That's 4 over 1, or just 4. And the cosecant of theta is 1 over sine. So this is going to be 1 over negative square root 15 over 4, which will be 4 over negative square root 15, or I guess you could write this as negative 4 square root 15 over 15. Okay. All right. Some more examples. All right, so now let's say here we're given the value of the tangent, and the only other information we're given is that the cosine is negative. Well, that should be enough to tell you what quadrant the angle's in, because the tangent, if the tangent is positive, that means the sine and cosine have to be of the same sign, and the cosine is negative, so that means the sine is negative. Okay, so we're talking about the third quadrant. Okay, so the sine and cosine will both be negative. All right, so now let's go ahead and find out what these other values are. Well, we're only given the tangent here, so why don't we use an identity that involves a tangent? So we know that 1 plus the tangent squared is equal to secant squared. Okay, so plugging things in, we get 1 plus 2 squared equals secant squared. So this is 5. And now we can take the square root. We can take the square root of both sides. And so this is going to be plus or minus square root of 5 equals secant theta. Now, which do we take, the plus or minus? Well, we know that we're in the third quadrant. And since here the cosine is negative, that means the reciprocal of the cosine is negative, so the secant is negative. So it's going to be negative square root 5. That's the secant of theta. Okay, and then we can take the flip, we can take the reciprocal, and we get the cosine. So the cosine of theta would be 1 over negative square root 5. Okay, and I'll leave it to you to rationalize that. We also know that the okay, so now if let's say one other thing, we know the tangent is 2, so the cotangent is the reciprocal of the tangent. So that's just going to be 1/2. And if we wanted to find the sine and cosecant, those are the only two left. We now know that we can pick whatever fundamental identity we want. Let's say use the original fundamental identity, sine squared plus cosine squared is equal to 1. And we now know that this is, the cosine is 1 over negative square root 5 squared. So this is, sorry, this should be, we'll switch this around. And this will be the sine squared theta equals 1. And so this is 121 over 5. We square this, plus sine squared equals 1. So sine squared of theta equals 1 minus 1/5, which means sine squared of theta equals 4/5. And so sine of theta is going to be plus or minus the square root of 4/5. And what is that? That's going to be which sign? We're in the third quadrant, so sine is negative, so this will be minus square root of 4/5, or minus 2 over square root 5. Okay, again, you can rationalize this if you want, but I accept either one of these. And then the cosecant of theta is just the reciprocal of the sine, so this would be square root of 5 over negative 2. Okay, so that's 1, 2, 3, okay, 4, and 5. Okay. So we were able to get all of these from this example. This just was this piece of information. Okay, let's do one more example here, example 5. Here the values, their cosecant of theta is 7/4, and the tangent is positive. Here we can see this is the same as 1 over cosine. So the cosine's positive, and if the cotangent's positive, so that means the sine is positive, so we can see that theta is in the first quadrant. Okay, so everything is positive here. we immediately see that the, I'm sorry, by the way, this is sine, shame on me. Sine, but still, sine is positive. Okay, sine's positive, tangent's positive, so the cosine's positive. So the sine of theta will be 4/7. That's just the reciprocal of the cosecant. And we can just go ahead and now you know the sine, we can say, use the fundamental identity. So this is going to be 4/7 squared plus cosine squared equals 1. This is 16 over 49 plus cosine squared of theta equals 1, but we can rewrite this as 49 over 49 because we get this, we need a common denominator. And 16, so we can see the cosine squared of theta will be 49 over 49 minus 16 over 49. This will be 33 over 49. We can take the square root, and so this will be the square root of 33 over 7, because the square root of 49 is 7, and we already know that cosine, we're in the first quadrant, so cosine is positive. And this also tells us that the secant will be 7 over square root 33. Okay, and then the only other thing we have to do is find the tangent. Well, find the tangent and the cotangent. We now know the sine and cosine, so we can just write everything in terms of sine and cosine. So the tangent of theta is, so the sine is 4/7, and the cosine is square root 33 over 7. And you can check that this will be 4 over square root 33. Or if you want to rationalize it that way. And then the cotangent is the reciprocal of that. So this will just be square root 33 over 4. Okay, so that's 1, 2, 3, 4, 5, and 6. Okay, so where we got it. Okay, again, so easy when the professor does it. You need to get some practice now. So just go ahead, start working on the problems, and we'll see you next time.